Math 1343, confidence intervals, inferential statistics. Before we review confidence intervals, I feel like there's some even more general concepts we should review from statistics 1. The first of which is the concept of inferential statistics. Without totally reviewing all of statistics 1, there's essentially two types of statistics. Inferential statistics, which is the majority of what we're going to do, and descriptive statistics. The goal of descriptive statistics is to describe a sample or a population, usually by means of calculating a value, such as saying the average of this sample is 12, or with some sort of picture, such as a pie chart, showing how student classifications are distributed in a class or something like that. But we're going to be dealing mostly with inferential statistics. And just a reminder, inferential statistics is any procedure in which some inference is made about a population based on one of its samples. This is how statistics works, and the reason inferential statistics is a thing when you compare samples to populations. Why don't we just measure the population and say something about it instead of relying on what one of its samples says? And the answer is usually twofold. A population in general is hard to measure or sometimes impossible for two reasons. Number one, the population might be too large. For example, let's say you wanted to calculate the average age of every US citizen right now. If you were to ask every citizen their age, that's a lot of people to ask. So the size of the population makes it daunting to actually accurately measure the entire population. And another reason measuring populations is difficult, if not impossible, is that populations are often dynamic, meaning that they're in a constant state of change. Going back to the example of finding the average age of all US citizens, if I were to literally line everybody up in a row in the country and ask them and record their answers, by the time I got to the end of that line, some of the people in the line will have already aged up, some people will have been born, and some people will have died because the population is constantly changing. The population is dynamic. So it's often difficult, if not impossible, to accurately gauge a population, and so we resort to inferential statistics. We take a sample, we learn something from it, and based on that we can say something about the population. I've got a couple of just word examples, and I'll show you what I mean by making some inference about a population. In the first example, let's say that we survey 100 students and their average GPA was 3.5. There's a couple of claims that we could make, or a couple of statements, a couple of inferences we can make about a population. For example, we could say, therefore, the average GPA of all students is 3.25. Now, can we rely on that? Probably not. Because when you take a sample from a population, there is no guarantee that the sample is perfectly representative of the population. Plus, if I took a different sample of 100 students, I might have gotten a different average GPA. So we can say things like this, but inferences about a population based on a single measurement from a sample are usually fairly unreliable. But there's another type of claim that we can make if we could create something called a margin of error. We could say something like the average GPA of all students is 3.25, comma, with a margin of error of, and then there would be calculations involved to finding this margin of error, but just for the sake of simplicity, let's say the margin of error, and I really want to spell the word error a little bit better there. But let's just say that the margin of error after however we calculate it, and we will get into how to calculate margins of errors. Let's say this margin of error was 0.12. Well, what would that margin of error mean? that means that we think for the whole population, the average GPA is this, but we've got some wiggle room either below or above 3.25 by this margin of error. So we could say that we claim that the average GPA is between 3.25 minus the margin of error. In other words, maybe we're off by that much on the lower side, which is 3.13. And maybe we're off by the margin of error on the greater side of 3.25. So if we add 3.25, we get 3.37. In a subsequent video, it looks like it's going to be the third video of the series, we'll talk a little bit more about what's called an interval estimate, where we don't say the population value is a certain value, but rather we say it's between one value and another. That's actually a confidence interval. More details later. So that's one type of inferential statistics we could do. We could make a claim about a population, or we could estimate a population value based on a sample value, either by saying the population value matches the sample value, but that's not very reliable, or based on the sample value, we can create a range of values, an interval of values, and say that the population value is probably between there with some confidence level. Again, we'll get into the details later. But there's a second type of inferential statistics which we're going to get into. You may remember something called a hypothesis test. That will show up next week, so I'm not too worried about covering it right now. But the gist of a hypothesis test is somebody has already made a claim about a population, but we have a sample that kind of contradicts that claim. For example, an economist claims the unemployment rate is 8.5%, but in a sample of 1,000 citizens, only 5% are unemployed. So here we kind of already are saying something about a population, that 8.5% of them are unemployed. So we're not really doing the same type of thing that we did up here, which is estimating something about a population. We already have a claim about it. In this context, though, we would pose a question. The question would be, is this sample sufficient evidence to reject the economist's claim? And the procedure for taking that sample's evidence, the sample of 1,000 citizens, 5% of which were unemployed, the procedure of taking that sample's evidence and testing the validity of the claim about the population is called a hypothesis test. And when the time is right soon, we'll review all the steps for doing that. It is very procedural, very straightforward. Both of these things are completely objective. We don't have to guess or anything. We just have to figure out what information were we given, how do we process it, and at the end we'll get our results. All right, so just a quick reminder of inferential statistics, trying to make some inference about a population based on a sample, and there's mainly two types. Estimating something about a population based on a sample measurement, or challenging a claim about a population based on a sample's measurement.